I'm the host of Data Debug. Thank you all for coming. So pumped to see you here. So pumped to kick the year off right. You already heard Sam kind of get into it. So excited he's able to talk today. He did our November talk, if you were able to make that one. He's just super knowledgeable, very technical. And, if you have any questions, keep them to the end because it should be a really enlightening talk. Yeah. Without ado, Sam, officially back to you now. Thank you so much.
Okay, so enterprise AI patterns, mouthful of a name, right? So who am I? My name is Goswami, and I struggled for about 4 years to kind of make the Starbucks barista get my name right before giving up. And then I became Sam Goswami. So let me reintroduce myself again. I'm Sam Goswami. I'm a distributed computing and data engineer. Clearly, I don't stay in a company for too long because I get bored. My last company was Replit. Prior to that, I've worked at Amazon, LinkedIn, Yahoo. I currently have a day job, which is not dual flow. I work as an observability consultant at PwC. Prior to coming to the US, I've also worked outside of the US in the Middle East and Europe, primarily again in the data space. Data, more of a distributed computing space. I think the data space emerged post 2015. Prior to that, it was more of the distributed compute. Okay, so back to enterprise AI. So to talk about enterprise AI, let's get to agree on a definition of what we call enterprise AI. Now, this part is fairly intuitive. It's an AI app that is built inside an organization to improve a business outcome. This is not controversial. This is the part where it gets tricky. Though it's built inside an enterprise, it might have public access. So a pharma company building an AI app for healthcare providers so that they can quickly kind of fetch knowledge out of a knowledge bank instead of having to go through a manual. So this is external, but this is not exactly the endpoint customer, but these are external customers. So there is a public access component to it. But what's not there is typically a direct revenue stream. So if you associate a direct revenue stream with an app, then it becomes a commercial app. So it's something like Replito Lovable. That's not an enterprise app. And what this means then is that it has to pay for itself. Now, if you're in the data space, you are probably aware of the fact that most data organizations and companies run like this. It's an overhead to the company. The data organization doesn't pay for itself. There's no product direct revenue that maps to a data organization. So you have to move a metric that justifies your existence. This is critical, and bear this in mind as we kind of go through the rest of the discussion. This will become more imperative. So why does an enterprise need an app? I mean, we have already discussed that there's no cost pool from there and you have to pay for it. So why do you need an app? So there could be many reasons. Customer experience, this is the most common one. I mean, where you have a chatbot, where you want to improve customer experience. Now, we have all dealt with EPBX machines for donkey years and know how painful they used to be. Things have become a little better. But again, a little bit of this distinction over here. If you're looking at a product like AT&T, where support is a feature and they have a customer-facing chatbot, that is probably not what we are talking about. We are talking about more like an HR chatbot within the company, within an enterprise, or a recruiting chatbot, which helps internal employees, primarily internal employees, to kind of move through things. So that's the kind of app that we are talking about. It could help improve employee productivity. I mean, pretty much every company is building a copilot. They're all building a search. They're all building a summarization. Even 10% companies. I consult with a few companies. There are 10 people in a company and they have a copilot of their own. I mean, I don't think you can get a promotion today if you don't build one of these, actually. So report generation, but some of these are actually useful, like the typically mundane and repetitive work. Report generation is a very repetitive work that can actually be automated by AI. There is operational automation. I personally believe that this is the kind of niche area where AI is super, super helpful. There used to be a lot of workflows which used to be very, very painful and pathetic. And especially when humans do this, they make a lot of mistakes. And these are unwarranted mistakes that keep repeating over and over again if you look in Jira trends. So these are good stuff to actually operationalize. And then there's a decision support system. Now, this is kind of one of those niche things where the CFO of the company needs to take a decision on whether to invest in a new initiative or not. And they need a quick summary of the current company financials. This used to be a very painful process where a whole bunch of people would actually summarize and aggregate docs, and then you have to go through the entire process, which is now almost near real time, where you can actually go in and fetch this information very quickly. This is pretty much what I could come up with, the different categories in which you can map AI apps. Now, what's common for all of this? That's the enterprise data. So all of these are based on enterprise data that resides inside the company. So let's talk a little bit about what are the characteristics of this data, enterprise data. This can be structured or unstructured. I mean, if you work with data, you know, I mean, the pain of unstructured data, but that exists. It comes from multiple different sources, nothing new. I mean, we have been dealing with ingesting data from multiple different sources for years. And it is typically controlled by RBAC policies. What is RBAC? Role-based access control. Not every user in an organization has access to every unit of data. This is very common. So these are things that we have to probably keep in mind when we build an enterprise application. So now you have enterprise data, and we have defined the scope of what is an AI app. And we have also determined that to get a promotion today, you have to build one of these or you won't. So this will be easy, right? Ingest all of this data into your analytic system and embed it into vector store, and you get an app, right? This works, right? I mean, there are hundreds of companies that are doing that, actually. Trust me, I'm not exaggerating. 100 is not an exaggerated number. This works. It doesn't work well, of course, but it does work. So let's understand this architecture, or this way everyone is trying to solve a problem. So what we just built is a semantic retriever. This is not new. So to understand this, let's take a step back, not too many years. We are not going back to the 1960s, but like about 10 years. Enterprise search is not a new concept, right? Enterprise search has been there for some time. I mean, Google brought or redefined search by their concept of inverted indexes. And they use TF, IDF algorithms or BM125. There's a whole bunch of algorithms. And the philosophical idea behind Google's inverted indices were brought inside the enterprise, where you could run keyword search. That is critical over here. That was not a semantic search. So if you had keywords and your documents had keywords, you could build an inverted index and run search on that. So this is not a new technology. This has been there for some time. This scales great, and if you can write, or if you can kind of give it the right keywords, this works well as well. Now, this was not enough because this misses out semantic context, but naturally, I mean, if you give it a full sentence and a well-formed sentence, it will tokenize the sentence into individual keywords and search for it, and it will miss out on a lot of keywords because they don't make sense. So there was no semantic sense in that. And this is where companies did try, I mean, especially the bigger ones, tried kind of pre-AI version of semantic search. I mean, there were multiple of them, word to vector, glove. There are many different algorithms that have been tried. The problem with this approach was that it is very hard to scale. I mean, there are semantic search has a two-step retrieval. You have to first retrieve the top K queries from whatever is your store. Vector store is today the universal store. It was not before. And then you have to re-rank them to make it relevant to the query. And all of this was driven by configuration, which needed a PhD to work for about 6 months. So this was the problem. This is a problem which is very hard to scale. So this is the problem now, which has been changed by embedding models. So once OpenAI released their first embedding model, this is now commoditized completely. Now, it's a very low-hanging fruit. You don't have to do anything. You need to just call an API, and everything is literally done for you. So this is why you can now embed everything into a vector store and build a semantic retriever, and from there, just slap an LLM on top of that. So LLMs are great with semantic generation, right? You have a semantic retriever, you get LLM, you front it with the LLM. Hey, Patrick. And you have built your first retrieval augmented generator. Now, this is a RAG. No. I would call this more of a poor man's RAG. I mean, even if we add memory context to it. Now, again, if something doesn't make sense, please feel free to kind of catch me later on. But even memory as in conversational memory to it, so that you're not being repetitive. Even we have add memory context to it, it's still kind of okay, not great. The biggest problem with this kind of a system is that it does have a semantic retrieval context, but it's also an LLM which doesn't know how to say no. So it will try to fetch a doc or kind of ground its answer on a doc, but then when it doesn't find that, it will politely hallucinate and give you complete utter garbage, and you can do nothing about it. So what you can do is you make this not the only LLM or not the only source of truth, but add a validator on top of it. So essentially, you now create a small loop where you assign some score to the validator, and this could be a very simple logic to the validator. You just check whether this answer is rooted in a document source or not. That's pretty much all it's checking. And you have now just built a minimal RAG. This is a working RAG, which will get you answers which are correct like at least 60% of the time. This will not be super performant. Of course, there are some issues with that. We'll go into that. But it's a RAG, and it is useful. So this pattern of building a low-intensity RAG, this is a low-intensity RAG, as in we are not really sophisticating our retrieval. I mean, it is still, your generation is still retrieval augmented, but in a kind of very brute force way. This is called the reflection pattern. The retrieval is not called the reflection pattern, just to be correct. The reflection pattern is the worker and validator, which is having a monologue. The worker thinks, kind of sends it to the validator validates, either goes back to the validator, goes back to the worker to do the job again, or goes out and fetches an answer. This is the reflection pattern of enterprise AI application. So this is the first pattern. So let's take a step further. We built our naive RAG, which is useful, but let's think about it. Now, you had a data store. What we did with the naive RAG is that you had a data store and you dumped everything into a vector DB. From there, you build the RAG. But think about it this way. How did the data get into the data store, right? We have been doing ETL for years, right? I mean, that is not a new thing. I mean, this problem is already solved. In the company that you build this one, this problem has already been solved by data engineers who ETL stuff into the data store. But that's not where ETL stops, right? I mean, ETL does a lot more. I mean, it goes into building other layers. It goes into building facts and dimensions on top of the data, the raw data that was ingested, so that you can make sense of things. So there is already a data warehouse living in your system. That's probably already done. I mean, like, and if not done, I mean, this is a very tried and tested, auditable, traceable way to provide insights. You're still trying to provide insights. The objective has not changed. You're just trying to provide insights quicker. But this, if your data is already in the data warehouse, then you can still get very quick insights by simply writing SQL. But you don't want to write SQL. Okay, we can deal with that problem. So build a SQL agent. This is also commoditized, very low-hanging fruit today. SQL agents are super simple to write. Natural language to a SQL query. Any kind of decent model can do that very well. I mean, even without the data context, it can still do that very well. So let's not go into the qualitative assessment of the thing, but you can have a SQL agent. And for the rest of the stuff, you have a standard retrieval agent. Now, of course, this architecture will need a little bit of routing. So you have an orchestrator which orchestrates the query to the right engine, and then again on its way back, I mean, parses the engine, composes the thing, and a validator still validating the result. So what you have is a multi-agent pattern. This multi-agent pattern can go really crazy. And again, it's not always technology that drives things in a company. There are modern methods which kind of, the way it works is you cram a bunch of different models over here, which instead of one validator, each one of them debate with each other about the veracity of your answer or the quality of your answer, and each of them validates it. And there's a chairman in the council which finally makes the decisions and do. So you can go batshit crazy with this. I mean, that's my point. And essentially, this is called agent council. I don't really believe that this is a very different pattern. I haven't put them in the summary patterns, but it's an augmentation of your multi-agent pattern. If you already have multiple agents, you can probably do something like this. The next pattern. React. This is not your front end React. This is reason and act. Now, React is a framework that has been used since the early days of agentic system. So, I mean, the first version of agentic system, and the whole reason of actually splitting LLM personas into multiple things was so that you can reason and act. Essentially, how this is different from what we have discussed before is that you take a big chunk of work, you split it up into small chunks, you reason about each work, act on it, look into the output, look into the quality of the output or the accuracy of the output, and then based on that, you build up. And this is the classic reason and act framework. So why not add or kind of superimpose the reason and act agentic system on top of our RAG data? So now this becomes, the validator becomes a planner or a planning agent, and the orchestrator becomes an action agent. It's fundamentally still the same idea. What they're doing now is the quanta of work that they're working on is probably much smaller to build on, and you go from there. This part of the agentic system, or this component, is the React component, and this pattern is called the planning pattern, where you plan and execute small components of work.
Real quick.
Sure.
Cloud code works with subscribers planning and instruction different agents.
Sorry, what was that?
Cloud code is kind of similar how that works.
Yeah, so that's a great question, actually. So all modern agents have reasoning inbuilt. That is the reality of modern agents. And now the way it actually works is that if you use Claude Code using a RESTful interface, like just making HTTP calls, you won't get the reasoning directly. But if you use it as a streaming provider, I mean, if you use the connection on WebSocket, then it will do exactly that. And it exposes even the thinking monologues. You can work on that. And that's pretty much every new model have reasoning capabilities. Now here, you are even architecturally boosting that reasoning capability and kind of making it even more powerful. Okay, so now the last one, but not the least. Till now, we have been talking about a closed corpus of information, enterprise data. We haven't stepped out of enterprise data, and the fundamental accuracy of the system and all the stuff that we tried to do was on making it grounded on enterprise data. That's why it's a RAG-based system, and we are trying to augment our retrieval mechanism in such way that you just don't step out of my corpus and go anywhere else. That's basically what we are trying to do. Now, the initial example that we took, the CFO needs a chatbot based on which it can take, the CFO, not it, the CFO can take decisions on new initiatives. Now, of course, the CFO needs the market sentiments. Now, market sentiments is global knowledge, and CFO of the company, I mean, come on, you have to give him that he's not going to go to ChatGPT and do it for you. Your system has to do that. So what you do is tool calls. So this is one of the hardest and most complicated architecture applications in terms of accuracy these days, where you are fundamentally based on a closed corpus, but you're making tool calls and getting external data as well, and then amalgamating both these sources of data to come up with your reasoning. It's obviously very hard. Accuracy determination, the accuracy scale completely changes in this case, but it's a very, very common and used pattern. And this is called the tool use pattern. Okay, so we rammed through a whole bunch of AI and architectural patterns. So let's summarize that a little bit. So reflection is the simple, any agentic system kind of starts with a reflection pattern. You just split up your generative component into two personas. I mean, it could be a worker, manager, or any kind of personas. And when Replit started, the first version of Replit only had two personas, as a matter of fact. Now Replit has like 28 personas. But then Replit initially had a two persona where your work is getting validated, and it's in a loop till the time you come up with the final solution. Multi-agent pattern, again, I mean, agents, horses for courses. You have multiple different agents doing multiple different things, and it is orchestrated and validated before the answer is presented to you. Finally, planning, break up a big chunk of work into smaller chunks and execute them. And tool call, where you go beyond the finite corpus of data that you started with and intelligently introduce new signals that could be very relevant to the question that you're trying to answer. Now, these are the four patterns that deep learning lists, I mean, on their thing. I mean, from a technical perspective, these are the four technical patterns. I mean, of course, when in reality, when these are implemented, some combination of all of these or some combination of each one of these are implemented. I feel it kind of makes more sense when you see the business use case of each of them and arrive at them from the business use case than the purely technological use case, if that makes sense. The question, though, is you learned about a library of enterprise AI patterns. So what? What's next? How does that impact me? I think that's a great question. And what's going on? Okay. This is important to understand. If you have some expertise or some kind of experience in the data world or data engineering world, I don't want to limit to data engineering, because who is a data engineer is a very hard question to answer today, because most of the data engineers or the analysts have been fired, and whoever you are doing probably both of them or all the stuff that the data org actually needs. Data has been organized in medallion architecture. I mean, everyone familiar with medallion architecture? I mean, if you're not, I mean, I'm happy to talk about them. I mean, essentially, it's a three-tiered architecture, and you don't have to be even familiar with the medallion architecture. The medallion architecture just gives it this name: bronze, silver, gold. I mean, this kind of three-tier architecture where you dump your raw data in a first layer, your data warehouse in a middle layer, and these layers don't have to be one layer. I mean, data warehouses can have multiple different tables and stuff. And finally, your domain-specific tables, which your domain experts like marketing, finance can query. This has been around for quite some time. I mean, like I think 2017 or 2018 is when this architecture, this terminology popped up, but then this architectural pattern has been there. This is already there. What is happening is all the AI patterns that we talked about. So there is a fusion of roles. That's the first thing that probably needs to be understood. Software engineers used to work with enterprise search. Data engineers don't really work with enterprise search. Insights was the domain of data engineers, and they do a good job with that. The reason this is kept this way is I'm given to believe, I've actually worked on both sides of the spectrum. I'm always told that software engineering raises the bar, and what data engineering do, no one ever tells me, but then it had different bars, which is why enterprise search apparently was a harder problem, which is why software engineering dealt with it, and data engineering doesn't. So those days are gone. I mean, like, so those illusions or delusions that people were harboring, those are gone. Now, what has happened is your data warehouse, your bronze layer is still there. I mean, ingesting production data from many different sources into your data store of the company. This could be a data warehouse, this could be anything. I'm not assigning a label to it. It's still there. Nothing has changed about it. You need your raw data. You need your raw data for the entire life cycle of however you have kind of structured your business facility. The silver layer now has a new component. This answering insights or powering insights from unstructured data was always a problem. Data engineers never did it well. I mean, there are many different ways, many different tools that have been employed to solve the problem. It has never been done well. Now you have a solution to that problem. So a vector DB solves your problem of augmenting your insights from structured plus unstructured data. Structured data, you're already solving with data warehouse. Now you have a way to get insights from structured data. So your silver layer is now the data warehouse plus your vector store. The most interesting thing actually happens in the gold layer. There are no dashboards that you can build over 6 months. Those don't exist anymore. And in the next 2 years, there won't be none. I mean, there are still big companies which probably have more dominance on the market, which still look for fine-grained metrics. They're vanishing very fast. And I'm talking about companies at the scale of Amazon, where there would be 3 data scientists working for 2 quarters to just see the number of marketing emails that should be sent so that it doesn't end up in the spam box. Those kind of metrics are not going to be built ever again, I'm telling you. And you don't even want a dashboard. You don't want a static dashboard. This needs the effort of 2 data analysts and 3 data engineers and 1 data scientist to build up. You need a real-time dashboard now. You are not bound by dashboards anymore. You have questions. You were never bound by dashboard. I mean, it is just the proxy to the best way to answer your question. You always had questions. Those questions were answered by dashboard because that was the limitation of technology at that point of time. Those limitations don't exist. So you have dashboard and you have questions. Agents will answer this question. And the silver layer or the intermediate middle layer will now have to adjust to building kind of better engineering pipelines or ETL pipelines that can facilitate and empower building any kind of agents, a plethora of different types of agents in the gold layer, which is now your source of insight. So you see, this is whose domain? This is the data professional domain. I mean, we didn't actually start with the data domain, but now we have completely moved into data professional's domain. This is what a data professional is supposed to do. Now, this is also, now question is, where is the opportunity? And I think that's a very valid question. This layer of the future medallion architecture, or whatever is that architecture going to be called, is very, very automated. So there's a whole bunch of companies which, a whole bunch of companies which do this well. And if you've been following the industry, Fivetran acquiring DBT, and all of this is towards this direction. There's very little human work left here. This is being done well, and and this will continue to be done well with very little scope for humans to kind of contribute to this, rather than messing this up. About the next layer, this is interesting. This actually has a very, very critical human component, the dimensional modeling of data, modeling data into facts and dimensions. A bunch of AI companies have been trying for the last 2 years to kind of build AI products over there and fail gloriously. This is a layer that really needs a human understanding of the business domain. It really needs multi-dimensional understanding of human domains. How do you distinguish between a charge off as against a refund? Can be very, very different and mean very different. So this is definitely a layer which needs, which has a very human kind of component to it, and this will continue to stay. But the rest of it, or the vector DB, this is just an API call, right? I mean, there's not much to do. So this layer is partly automated. And the last one, which is your gold layer. Oh, sorry, meant to thank you. This is greenfield. Literally, this is greenfield. No one knows what to build here. We all have questions, and we are trying to build the best system that answers the question. This is not a skill that data engineers have right away. I mean, a lot of data engineers have been learning the skill and improving the skill, or data scientists and data analysts, they've all been acquiring these skills. Products and interfaces are changing in this space. And this is where I believe there's a lot of things that are going to happen, and this is where you should be. Yeah, that's about it. If you are one of them, yeah, I'm just coming to the answer. I have a blog of this on the company Dual Flows site. If you want to read it, feel free to grab it. I mean, if this was very quick, so if this didn't make sense and I wasn't good at articulating, maybe I have better articulation skills when I write. So yeah, feel free to check this out. Okay, thank you so much. Any questions? Yeah, go.
For that silver layer,
Mm-hmm.
you're building the semantic model in data. Have you seen that out anywhere? When you think you should present it that well?
Yeah, that's a great question. So well is a very subjective concept. So this is actually a very important question. The definition of what is acceptable has changed, and it is changing every day. Accuracy, groundedness to 2 decimal places was probably a standard 2 years back. Now, proportion of groups is probably an acceptable standard. This is changing. And I mean, as business leaders or people taking decisions out of insights, you tend to see that you don't really need that level of accuracy to answer the questions that you are trying to answer. Now, yes, there are certain questions which need that accuracy. I mean, that and those are not, won't change. But do you really need a team of 20 engineers to do master data management? You probably don't. I mean, there's probably one company in the world that is still doing it. Most other companies will not do. So this doing what is the threshold of accuracy that is acceptable to a company is changing and transitioning. And that is transitioning at the same rate at which technology is moving. So this is the new reality we are living in. That answers your question? Okay.
One last question.
Sure.
Sam is awesome. I love that talk.
Okay.
I know we all.
We have the
Questions?
networking
And
after this.
afterwards, we'll have time.
Sure.
Afterwards, I promise. So one last question.
Anyone? Oh, okay, Patrick.
Does the, and it's okay if you're like super familiar with it, I'm barely familiar with it, but does the validator remind you of in deep neural networks when you are like forming images and you have thank you, when you're forming again and you have your adversarial who's like verifying in results, right? Does that like ring bells for you just saying like it can't do it versus like a vacuum.
Yeah, that's a great question. So in this presentation, I mean, what I meant was more of a naive validator, and which is like a two back and forth system. These are very simple agents, and which I mean, this is threshold based validation essentially. This is obviously in actual implementation, they can be very, very sophisticated, and you rarely have a one-step validation. It is probably almost always a mix of the reflection and the planning pattern together, where you're first breaking things up into chunks and then validating them using a reinforcement learning based conversation back and forth, which is typically how production systems are built. And this is exactly because when you actually build a system with a kind of naive validator, you run into the same problems. That threshold doesn't work and the loop keeps going on, which is where actual implementations are probably a little more sophisticated than that. Yeah, that's the thing. Okay, thank you so much. I'm available. I mean, the networking hasn't stopped. Happy to answer.